Okay, so this standard 12.4 is all over Earth science, and you guys started you studied Earth science way back in 8th grade. So you got to remember all the way back to 8th grade what you guys studied. So this first 4.1 is on Earth and space. And so the first standard says students will investigate and describe the known universe by describing the formation of the universe using the Big Bang Theory. Not the TV show and Sheldon Big Bang Theory, but the actual Big Bang Theory. And what? And Penny. The evidence they use for the Big Bang Theory is that the universe is expanding. Okay. And it's expanding faster and faster. And
You mean like it's accelerating in expansion?
what? Yeah. Yeah. What?
You mean like it's accelerating in its expansion?
Yep.
No, I didn't know that.
Recognize that the stars, like the sun, transform matter into energy by nuclear reactions, which lead to the formation of other elements. Nuclear fusion. So it takes simple elements. So it starts off with hydrogen, and it converts that into helium. And then goes on helium. Once it runs out of hydrogen, it'll convert the helium into a heavier element, and eventually heavier and heavier elements until it can no longer fuse them together and it dies. The sun would and stars would die. Which brings us to the stellar evolution, and that's what the next little chart. Oops. And when I printed these, or when I saved them, I didn't realize that the picture that you had been cropped. So you may want to write in a few things that are not on your chart, on your little diagram. But all the stars start from the stellar cloud with protostars in them, and then they develop into large stars or small stars. Our sun would be considered a small star, and then it converts through to a red giant, planetary nebula, into a white dwarf would be the end product of our star, of our sun. Large stars develop into red supergiants, supernovas, and then either a neutron star or a black hole once they've ran out of their fuel. Well, if we would have looked at that very first page, I think it says 2 to 4 questions come from the standard. I would guess something about the star evolution would be one of those questions, but just taking a stab, I don't know. Okay, Earth structures and processes. Students will investigate the relationships among Earth structures, systems, and processes. So recognizing how Earth materials move through geochemical cycles, which we talked about, carbon cycle, nitrogen cycle, water cycle, oxygen cycle. Those are all the geochemical cycles. Do you guys want to go over those again? You got it? Okay. It's the carbon, nitrogen, oxygen, and water would be 1, 2. Describe how heat convection in the mantle propels the plates comprising Earth's surface across the face of the globe. It's called plate tectonics. Do you guys remember that term, plate tectonics? The plates are moving, and there's different kinds of fault lines, like the convergent, divergent, all those. You could make mountain ranges. There could be canyons. They slide past each other, and that's where the earthquakes occur. But that's all based on convection in the Earth's crust. So this next picture shows how the Earth's core is, remember, convection is heat movement of fluids because of heat. And so the inner core of the Earth is a fluid, right? It's molten lava and rock, molten rock. So it's moving, convection is occurring, and that causes the plate shift, the plate tectonics. Evaluate the impact of human activity and natural causes on Earth's resources: groundwater, rivers, land, fossil fuels. So we're always talking about conservation efforts. trying to conserve the natural resources that we have. And that can be through like an Axeman. Who watches Axeman? No one? Isn't it on the History Channel or A&E or something? Yeah. Well, when they are cutting down those forests, a lot of times they will plant new trees to replace what they've done. That's part of conservation efforts. The Keystone Trans-Canadian Pipeline is a big deal right now, trying to conserve our groundwater, the safety and use of our groundwater. Those are all different conservation. Conserving water when you brush your teeth. Don't let the water run while you brush your teeth. Turn the lights off when you leave the room. Fossil fuels. You guys all know what the fossil fuels are, right? Like oil, coal, crude oil, gasoline. Okay. And then groundwater from the aquifer. Okay, energy in Earth systems. Describe how radiation... students will investigate and describe the relationship among the sources of energy and their efforts on Earth's system. So describing how radiation, conduction, and convection transfer heat in Earth's system. So we've talked about those kinds of heat transfers already in Standard 2, right? Radiation is a big one for the Earth in general because we get all the energy from the sun, the heat from the sun through radiation. Also, the Earth, and this is part of the 4B or 3B also, but the Earth radiates heat as well. So it either stores heat from the sun or it has the molten core that's releasing heat, and it releases the heat also. And so, like when you're driving on pavement and you see those wavy lines, that's radiation heat coming up, and that's not necessarily from the Earth's core, but the pavement gets hot and then it radiates heat. If you have ever noticed that on cloudy nights it doesn't get as cold, clear nights gets colder than cloudy nights because the clouds hold in the heat energy that the Earth is releasing, because we're not getting any heat from the sun during the night, so it's holding in the Earth's radiation energy. And so clear nights, the radiation heat goes all the way out to space and we lose it. So clear nights are normally cooler, a lot colder than cloudy nights. Conduction is through heat, like touch of molecules, through touch. Compare and contrast benefits of renewable and non-renewable resources. What's the benefit of renewable resources? You never run out. What are some of the renewable resources that we have? Water, sun, and what?
Not sun.
Elements? Like nuclear energy? Air, wind. Wind, sun, and water are probably the most common renewable energy sources. Describe natural influences like Earth's rotation, mountain ranges, oceans, differential heating on global climate. So Earth's rotation, jet streams are caused partly by the Earth's rotation, and so the jet stream, like we've heard a lot about the winter vortex, but the jet streams move in which direction generally? West to east. They move from the west to the east. Think about how storms usually track. They usually go northeast, right? And they're going eastward. The jet stream will move to the east. Do you guys know what the jet stream is? Okay. It carries in the fronts, the cold and the warm fronts. Okay. Mountain ranges can affect climate because mountain ranges, have you heard of the rain shadow? Heard that term before? Eastern Colorado and the Panhandle of Nebraska are in the rain shadow of the Rockies. We're right on the edge. We sometimes are considered in the rain shadow even. But where the warm air, warm moist air from the Pacific coast is coming across and it hits the mountains, the Rocky Mountains, what does it have to do? Can't go through them. Go up, and it's really cold up on higher atmospheric pressures, right? So a lot of that moisture will then condense, and it gets released on the east side of the mountains. That's why most of the ski slopes are on the east side of the mountains, because they get a lot more snow than on the west side. So you have lots of precipitation right there on the east side of the mountains, and then the air has lost all of its moisture, and it keeps moving west, and so there's no moisture in the air to be dropped anymore. So that area, the eastern Colorado and Panhandle, is a lot dry, arid climate. Oceans, big bodies of water, will keep the temperature pretty constant in that area. It takes a lot of energy. The water will just stay the same temperature. It takes a lot of energy to change the temperature of water. And so that water keeps the air around it at a constant temperature. So like San Diego is about at our same latitude. We're the same distance from the equator. You'd think we'd have the same temperature, right? We're the same distance from the equator. But we all know that's not true. I think San Diego has an average normally in the 70s. It's pretty much temperature all year round. Okay? And that's because they're right by the water. So it keeps the air at a constant temperature because the ocean is that. Also, in the Northeast, they get a ton of snow, right? Up in New York, and that's called lake effect snow. A lot of that snow is called lake effect snow. Have you heard that term before? No. Well, the Great Lakes are big enough bodies of water that they act similar to the ocean, but in the summer they get really warm, and it takes a lot of energy to cool them down. It takes a long time for them to get cold. So as the Canadian air moves across them, it picks up all that moisture, and it condenses, and it gets dropped on the east side of the Great Lakes, and that's called lake effect snow because it's picking up all that moisture from the lakes, which is why they can get feet and feet of snow. Did you just say I'm glad we live in Nebraska? No. Oh. Not that much, no. Yeah. Earth's history, 2 to 5 questions. So you'll notice that a lot of these questions, 2 to 5, 2 to 4, 3 to 5, so a lot smaller amounts of questions come from Standard 4. So students will explain the history and evolution of Earth. Recognize that any sequence of sediments or rocks that have not been overturned, the youngest sediments or rock are on the top of the sequence and the oldest are on the bottom. We talked about that with the fossil record in the 3rd standard. Interpret Earth's history by observing rock sequences using fossils to correlate the sequence at various locations and using data from radioactive dating methods. So being able to date old things, and that's what they use, radioactive dating. Carbon-14 dating is common. Gives you a very rough estimate. It's not 100% accurate, okay, because I know they've dated some things that they know is from a certain time period, and it dates it way older than what it really is, but they use it as a base. Yes, Colby. I don't know. And they use what's called, because they're carbon-14 dating uses carbon-14, obviously, and that's radioactive, meaning it breaks down and it breaks into other elements, actually. And so the half-life is how long it takes for half of that substance to be gone. So, like let's say you have 20 grams of a sample and its half-life is 10 years. So after 10 years, if you had 20 grams to start with, how much are you going to have left after 10 years? 10 grams. After another 10 years, how much are you going to have left? 5 grams. After another 10 years, right, it just keeps getting split in half. Are you ever really going to get rid of it? Technically, no. You'll get very minuscule amounts, but technically you will never get rid of it because you're always just losing half of it, and half of it's always remaining. I'm guessing there will probably be a half-life equation or question. That would be an important one. And this is next Tuesday and Wednesday, remember. So senior, make sure you bring something to work on Tuesday and Wednesday next week. Yep, put that away right now. Okay, not right now. Flip it over. There you go. Okay, so we have plenty of time to go over the questions in class. So why don't you go grab your clicker. Oh, man.
Tuesday will be the first two, Wednesday will be the last two?
Nope, it'll be mixed over the whole thing. So there are 60 total questions, and they'll be split. You'll have 30 on Tuesday, 30 on Wednesday. So I don't think it should take you more than the period. You're taking it in class. It should not take you. No. So as long as the class as a whole passes, we're going to have a movie party. A movie party. Yeah, it's the real thing. Tomorrow is our one over this. Just over the standard, over 12.4 tomorrow. So what is the major source of heat in the core of the Earth? We didn't necessarily talk about this one, and there's one that looks like a really good answer, but yeah.
That makes sense.
Yeah? Push clear.
So if that were true, then what would our outer nuclear? It'd be pretty hot. Just saying. And then like even the distance.
It's not letting you change? Did you push the arrow that looks curved? Answer is... Who put ABC? Answer is D. So A is the one that I would say probably looks right also, but it's actually D. So compression, because there's a lot of pressure in the center of the Earth, and when the stuff is under pressure, it usually heats up. But the actual energy comes from the nuclear decay. Okay, since 1980, there has been a decline in the overall amount of water in the Ogallala Aquifer. What may have caused this decline? Okay, the answer is lots of C's. It is C. Yes. Okay.
I was thinking, why did you first B?
Right. Increased rainfall would increase the water in the Ogallala Aquifer. Which heat transfer causes continental drift? You guys know what continental drift is, right? Where they're drifting Pangea and it's moving apart. Yeah.
Is it like 16 inches every year?
I don't know what
I
time.
think it's actually smaller.
16 sounds really big. But, oh, it's raining.
Raining it is. Oh.
That's good. We need rain. I love rainy days.
So do I.
We have a lot of people that haven't answered yet. Come on.
Ben keeps talking to me.
I'm already done, Colby. You number 19.
Yeah. I'm just gonna.
Okay, the answer is C. Yes. Oh, what?
Why did we skip like 3 questions?
We did? Oh. Don't you go left to right and then? Huh. I don't know. Which statement about the nitrogen cycle is false? Bless you. Okay, the answer is, pretty wide range. Whoops. D. Plants absorb nitrogen from where? From the ground, right. When you think about fertilizer is used to add nitrogen to the soil, and you put fertilizer on the ground into the soil, right? You don't spray it or whatever. You usually are trying to get it into the ground. So plants absorb that nitrogen. Animals get their nitrogen from eating plants, and then they would excrete it as waste, like in urine. The urea that you produce, it has nitrogen in it, and so it gets put back into the ground then, and it recycles over. So even if you don't use artificial fertilizer, I have a friend that they do have a manure spreading company, and so like farmers that don't use the ammonia and stuff, they can use manure and they spread it, and that would be a source of nitrogen also. Yep. Or how many of you your parents or something spread manure on the garden, or like chicken? I know a lot of people have chickens. They take their chicken waste and they put it on their garden because it's really good for the garden. Yeah. Right. Or compost, it breaks it down and it would have nitrogen. Not the actual grass clippings, but letting it compost into.
So what is that without nitrogen?
I don't know. Okay, what stage in stellar evolution is considered the birth of a star? Try to do it without looking at that little picture. Three, 4, and 10. Okay. Answer is C. It is protostars. The other 3 are the end product of death of a star. Okay, which sequence represents the life cycle of a typical star? So we know what it should start with. That should get rid of 2. Remember when you take your test, you have that tool that X's out. I don't know what it's called, what the tool is called, but it will put a big red X on the question that you want to X out, since you can't cross it out with your pencil. There is a tool that will let you do that. No, you can't. Or a permanent marker. They frown on that too. Washable. It has to be washable.
Okay, so for right now, this week's magic marker erase marker. We get caught.
2, 4, 6, 10.
Oh, I didn't know we were on another question.
Oh.
Well, geez.
Sorry.
The answer is C, yes. It is C. We said protostar has to be the first, because that's what we just said in the last question. And then we said the Earth, the sun in the Earth's solar system is a small star. Whoops. And so it would end in a white dwarf. What property of a star that determines its life cycle? It's push. I push start. This one has two that would be right. We didn't really talk about this one either, so no. There's not two that's right. There's one that looks like it would be right. It is brightness. And I would say mass probably is what I would do right away if you were unsure, because we talk about small stars and large stars, but we determine that by their brightness. Which element transformation occurs in a main sequence star to generate energy? I know. It should be ABCD, not ABCC. Answer is B. Hydrogen to helium first. B. Hydrogen to helium. Those are the first three. I don't know how we got them skipped, but life on early Earth was bombarded by solar radiation. What protective gas was absent in the early Earth atmosphere? So which of these gases protect us from UV radiation? And it was missing in the early Earth atmosphere. Answer is ozone. Yes. Do you guys know what the formula for ozone is? O3. Yep. Yep, and it's protective. Well, here's a half-life. We do need to talk about this one. This is a good half-life question. So sample A has a half-life of 5,000 years. If a fourth of it is remaining, how much time has passed?
10,000. Well, easy. Makes sense.
This one tripped up some people earlier. Answer is C. Yes, 10,000. Think about, okay, so how many half-life have gone by? So if we start with sample A and 5,000 years go by, we're left with half of sample A. And then half again is a fourth, so then we have, that's the second half-life. Or if you take a half times a half, so a half twice, that's a fourth is left. If we took 3 half-lives, we'd have a half times a half times a half, so we'd have an eighth of it left. Right? So that's how you could figure that out. So it is 10,000 years. In an area, last one, area where a river has eroded a canyon, such as the Grand Canyon, which rock layers is most likely the oldest?
The layer with most pulses.
Answer is D, yes. So the very lowest layer is the oldest layer. The very top layer is the newest layer.